We are going to go back to using the regression feature of our calculator to learn how to choose a model. There are three different functions that we studied in Algebra 1. One of them is the linear model. Another is the exponential model. And our last function that we studied was our quadratic function. The linear model or linear function represents a straight line. The exponential function, we know, increases exponentially. And our quadratic function is the graph of a parabola. So those are our three functions. We want to graph the set of points and then decide which model is most appropriate. So sometimes by looking at the data, we're going to be able to tell whether or not we have a linear, exponential, or quadratic function. So I'm going to start by graphing the set of these ordered pairs on the first graph all the way to the left. So negative 3, 6. 1, 2, 3, 4, 5, 6. Negative 2, 1, 2. 0, negative 2. This is looking kind of linear so far. 1, 2, 3. 1, 2, 3, 4, 5, 6. Whoa, that's definitely not linear, but maybe that is an outlier. 1, negative 1. Oops. 1, negative 1 is right there. Yeah, no, this is not linear, that's for sure. And then 2, 2. So this, if I had to make a guess, looks most like a parabola. Now I'm going to show you why this is quadratic. So I'm going to make a table. And I'm going to order the x's from least to greatest. So negative 3 is the smallest x value, and it has a corresponding y value of 6. Negative 2, positive 2. And then out of 0, 3, 1, and 2, 0 is our next one. And then they kind of went out of order here. So 1, negative 1. And then 2, 2, and 3, 6. 2, 2, and 3, 6. So let's see what's happening here. It looks like our data, adding 1, adding 4. Okay. The next time I add 1, we add 1. Then we add 1, and then we add 3. And then we add 1, and then we add 4. So it looks like, very much looks like, let's go back over here. We added 2, and here we added 4. So it looks like we don't have a constant rate of change. So this rate of change is not constant. And it looks like it's really hard to tell what's going on here because we've got going up by 1, then going up by 2 on the x's, and then going up by 1, going up by 1, going up by 1. But we could see that this rate of change is not constant. That is important. We started a positive, then we decrease, then we go back into the positives. So this right here says my y values, right? They're going from up here, and then the rate of change is not as much, and then it starts increasing again, right? Then it starts increasing again. So something is happening there that's making that quadratic. So this first one is definitely quadratic. Okay, the rate of change is not constant. So I'm going to write quadratic here, quadratic. So this one's definitely quadratic, and that's y equals ax squared plus bx plus c. Our next graph, we're going to plot these points right here in the middle, negative 2, 5, 1, 2, 3, 4, 5, 0, 3, 1, 2, 3, 1, 2.5, and then 2, 2. Now this kind of looks linear, however, I'm gonna look at that table and see what that rate of change is. If it appears to be pretty constant, we're gonna go with it. So from least to greatest, our ordered pairs are already listed and with respect to x. So negative 2, 5, 0, 3, 1, 2.5, and then 2, 2. So here we go up by 2, we go up by 1, we go up by 1. So this is our change in x. Our change in y, we subtract 2, then we subtract 1/2, and then we subtract 1/2. Okay, so this right here, so let me see, negative 2 over 2. Look at this, negative 2 over 2. Negative 2 over 2 is negative 1. But negative 1/2 over 1 is negative 1/2. Negative 1/2 over 1 is negative 1/2. This rate of change is iffy. So I'm going to say it's not constant. It's not constant. It's close though. It's really, really close. But my concern is what I'm seeing here is that curve like that. And we know that if that curve continues, what are we going to have? We're going to have exponential. So we're going to hold on to this one for a minute. My guess is that this is exponential. So I'm thinking that this is exponential, which is y equals a times b to the x. We remember that from our exponential days. And let's take a look at our last one. Now we might change our mind on this. We might think that it's linear, but let's see. Let's see what, maybe this next one will be linear, and we'll see what a linear one really is supposed to look like. Negative 2, 4, negative 1, 2, 1, negative 2, and 2, negative 4. Oh yeah. This one right here, definitely. This right here, I think, is linear. So this definitely looks like we've got a constant rate of change. So let's look at that. Let's look at the x and the y's and compare just like we did with the others. We had negative 2, 4. We had negative 1, 2. We've got 1, negative 2. 1, negative 2. And then I believe we had 2, negative 4. So our change in x, add 1. This one's add 2, and this one is add 1. Our change in y, subtract 2, subtract 4, subtract 2. So we're going to have negative 2 over 1, negative 2 over 1. So our change in y over our change in x, negative 2 over 1. And then we have negative 4 over 2. And then we have negative 2 over 1. And these are actually all equal. So this is a constant rate of change. So the rate of change is constant. When the rate of change is constant, we know for sure that we have a linear model. And that linear model is y equals mx plus b. So that's what we're going to be doing in these next few examples. We're going to choose models. Now, what I demonstrated for you right here is choosing a model by graphing. Choosing a model by graphing. Here is one for you to try, and we're going to come back and look at your 3 graphs, the one for A, B, and C, and see which models you chose for each one by looking at the graphs.